Okay, so far we've talked about how heat can change the state of a material. So when you add heat to a material, it can change from a solid to a liquid or from a liquid to a gas. Now we want to explore how can pressure affect the state of a material. So in case number one, over here on the left-hand side, we want to talk about how does it affect the boiling temperature of a material. So in the upper picture there, it shows some H2O molecules, so water molecules that are in a liquid. Okay, then what we're going to do is apply heat to this. So when we apply heat to it, it's going to start to make each of these water molecules start to move faster and faster. And if they have enough energy, they can break free of the water and then they end up out here somewhere. So therefore the water is boiling, the water is evaporating. But what would happen if there is outside pressure acting on it? So if we increase the pressure acting on the system, then what that's going to do is make it more difficult for these water molecules to be able to break free and then to end up out here. So that means we have to increase the temperature in order to give these molecules enough energy to be able to break free. So the rule is going to be that if we increase the pressure on a fluid, then that means that it's going to increase the temperature at which it's going to boil at. Now, what about, though, freezing? So how does pressure affect the freezing point of water? Well, in this case, so here again is going to be the water molecules, and what we want to do is to freeze them. So under conditions of low pressure, it's very easy for these water molecules to lock together and then to turn into ice. But what would happen if we increase the pressure? So if we increase the pressure, what that's going to do is it's going to force oxygen and nitrogen air molecules out here, and it's going to force it into the water. And so if those molecules are in the water, they get in between the water molecules, and therefore the water molecules cannot lock together to make ice. So what does that mean? It means that now we need to decrease the temperature until they can lock together, because at this temperature that it currently has, these molecules are moving too fast to be able to lock together and force out the oxygen and nitrogen that's in the water. So what we're going to need to do is lower the temperature of the water, make these water molecules move slower so it makes it easier for them to lock together, and then when they do that, what it will do is it will force out the oxygen and the nitrogen back into the atmosphere here. So what's the rule? So if we increase the pressure on a liquid, it's going to decrease the temperature at which it's going to freeze at. So that's the effect of pressure on the boiling point of liquids and then the freezing point of liquids. So this is also going to be true for other kinds of substances. So it doesn't necessarily have to be water. All right, now what we want to do is let's see what effect do additives have. So when you add basically solids to a liquid, what is that going to do to the boiling point of that liquid? So in this particular case, over on the left-hand side, we're talking about salt. So what is salt going to do when you add it to a liquid? So when you add it to the liquid, the salt molecules are going to break apart into sodiums and chlorines. Remember that salt is NaCl. So it's going to break apart into the sodiums and the chlorines, and then the water molecules are going to surround the salt and the chlorines. Well, then if they're attached to the chlorines and the sodiums, then that means that it's going to be harder for those water molecules to break free because they're attached to those. So what does that mean? You're going to have to increase the temperature, make the water molecules move around faster to give them enough energy to break free of that salt and then to escape. So the rule this time is going to be that this time we're going to increase the amount of, how about A for additives? Then that's going to increase the temperature at which water is going to boil at. All right, now what about additives? If you add additives to water, how is that going to affect the freezing point? Well, once again, let's use salt as an example. The salt is going to get in between the water molecules, and it's going to make it hard for the water molecules to freeze. So therefore, what we need to do is to lower the temperature of the water, and then eventually the molecules will be moving slow enough that they'll be able to lock onto each other and force the salt out of the ice. So in that bottom picture there, you see the salt molecules have been pushed out of the ice. So an example of this is in glaciers. So you have salt is dissolved in the oceans, and then as the temperature drops, it starts to make sea ice. And as it forms sea ice, it forces the water out of it. So actually, glaciers are even the kind of glaciers, icebergs, that you find in the middle of the ocean. You can drink the water that comes out of them because all of the salt has been pushed out. Okay, so this now explains how pressure affects the boiling point and the freezing point of water, and how additives such as salt also affect the boiling point and the freezing point. Another example of this is antifreeze, so that you put antifreeze in the water that goes into your radiator, and then what that does is it increases the temperature at which the water will boil at, which means that as the engine heats up, then the water is less likely to boil out of your radiator. Also, it lowers the temperature at which the water is going to freeze, so that keeps your radiator from freezing. All right, so that takes care of changes of state. Now we're going to take a break, and when we come back, we're going to look at the fourth consequence of what heat can do, and that is heat can be transferred from one place to another through these three mechanisms. So I'll see you in just a moment.